So I am at Google Cloud Consulting. I build AI production-ready systems for large Google customers, and mainly I lead teams nowadays. I rarely do heavy technical work anymore, which, for a moment there, I was wondering if I should go back to, and then I actually realized that in this, whole new world, I want to go back to data. So transitioning back into that, it's going to take me a little bit. Ask me about 6 months how that's going to look like. But let me tell you what I'm going to that was my QR code if you want to connect with me on LinkedIn. Let me tell you what I'm going to be talking to you about. I gave this talk last year. I think, did someone drop out and then you were like, hey, do you want to give a talk? So it was like a last minute fill. I'm filling in a spot for someone else. And so I'm going to give you maybe a little bit of a different overview of the world of AI. That is how to do business in AI. By the way, did I run into the street? Did I run into you on the street earlier?
Have we?
I have a feeling, yeah. No, I swear. We did, right? I was walking back. It was on Harrison.
Interesting.
Yeah, no, 100%. Okay. All right, so I'm going to tell you a little bit about business of AI and how to do it. All tech is obviously great. But a lot of times nowadays, we tend to focus on technology and not really focus on business. And that doesn't always work out. There is, especially with the hype, and early, about 3 years ago when the Gen AI hype started, when that kicked off this whole world that we live in right now, a lot of companies decided that they want to be AI first and rebrand themselves, but they really didn't know what that means. So they decided they're just going to, just throw this AI at me and then we'll figure it out. Now we can see that that's maybe not the right approach. There is a company out there that I'm not necessarily going to name that was really good at what they were doing. It's a large retail company. They had a huge part of the space. Probably some of them you're wearing their stuff right now, and they lost a huge portion of their market. Their stock, is not doing really well, and they're saying, they're lost their ways or whatever. And the part of the reason is because they try to, use a data approach rather than focus on actual business approach that worked for them for years. So how does that look like for AI? So number one thing that we're going to be looking into is we're going to go from consumer to enterprise and now to agents. Because what else is there to talk about? By the way, has anyone been out here at the Decasonic event today? No? Cool. It's a Chicago Tech Week, so many events. How many of you have been to more than just tonight event? Yeah? Cool. Which events did you go to?
In the past, I've been to the the Cybersecurity Summit in
Cool.
McCormick Place. And
Nice.
that was a few years ago, but even then, I must have been was it late 2023? And it was every presenter was AI, AI, AI. It was became a running joke that previously the Cybersecurity Summit was more traditional and started in late 2023 or around then. It was nonstop AI everything.
Yeah. You went to some events this week?
I just went to another one.
Cool.
It was called Leverage AI for Accessibility. It was just
Okay. Ooh, cool. Oh, that sounds really interesting.
Were you there too?
Yeah, it's Slava.
Yeah.
Nice.
Right there.
Well, it is Chicago Tech Week. If for those of you who maybe don't know, so many events around town, and it's a rare opportunity because of sadly many discussions about that Chicago ecosystem is not as vibrant as New York or San Francisco. Okay, so let's talk about enterprise to consumer, consumer, enterprise, and then agents. All right, so when we say consumer and AI for consumers, that's you can think of that as ChatGPT, for example. A very Anthropic is a consumer company. All of these companies also do B2B, but ChatGPT launched as a consumer first, right? It's a chat, you open it, individual users use it for the most part. Instagram, X, all of these companies, consumer first, obviously, a lot of retail. And consumer AI is great. And when you are working at home on your own, you maybe have one way of working and you're like, oh, I want to try, this really cool tool or this really cool model in Hugging Face that I heard about, and I'm gonna, trade on some whatever data, and like, oh, you can do all of these things, and that's amazing. You can do it at home. Maybe you're gonna find it use for like OpenClaw, right? Everybody went crazy for it. Consumers did. That absolutely makes sense. But when it comes to enterprise, where a lot of, when you think about the market, that's where the big money is. When it comes to enterprise, we have to think about AI a little bit differently, especially in regulated industries. At the event today, the Decasonic event, it is a Web3 Investor Day. And I usually go to participate in an AI panel for the past couple of years. And over there, everybody talks about regulated industries. So if you think about enterprise customers in regulated industries, the way we build AI, we approach it differently. Number one is, do you even have infrastructure to build AI? And then if you do, what is the problem that you're solving? I do a lot of enablement and education, and in the past year, I actually started talking a lot with non-technical small businesses. And the main focus is, because the small businesses are going to know their business, but they're not going to know technology, they actually don't know what's the best way to apply technology to solve the problem. And you can think of it actually as in a large enterprise as well. Maybe some C-suite has a mandate from the board, oh, you need to implement AI technology, but how do you actually do it for your business? It's not always intuitive, especially if you are not a technical person, a CTO. There are companies out there that are very technical, and from my experience, a lot of these companies actually still use traditional ML for a lot of their work. It's cheaper, it works better, especially if you have tabular data, it just works. Or if a lot of you are maybe from computer vision background, if you are in manufacturing, warehouse solutions, robotics, and so on, we have better data now. The robotics companies or robotics data is being collected. We have better data, like better quality data. And now with some of these pre-trained models, we can create better solutions, also in more old school way. So how do we decide what makes a good problem to solve? And that's what I'm gonna be talking about today and telling you a little bit about math. And then finally, agents. How many of you are here to hear about agents? Right? Everybody. This is my opinion. Agents, as I mentioned, have their place. It's obviously a technology that is incredible in many ways. It is not a new technology, but with the accessibility to large language models, it became accessible to everyone. On the enterprise or business level for agents, there are many guardrails and things that we need to think about. But at the end of the day, it is going to come down to, how do you build your infrastructure so that you decide what is the level of autonomy that you want to give to this agent that makes sense for the infrastructure that you're building and for the business problem that you're solving. If you're not solving for the real business problem, it doesn't matter how cool your agent is, how amazing it is, how many agents you can build, how many millions of agents you have. If you're not, at the end of the day, solving your business problem, or if you're just, having a very expensive bill to pay, it just doesn't make sense. Your business is not going to grow. All right, how many of you are working at the startup? All right, so how many of you are students? Cool. And then the rest are in corporate enterprise? Yeah, cool. All right, so start with the business, not with the technology. The first thing to do is think and talk about a feasibility versus impact matrix. All right, so feasibility versus impact. Let me see, I'm gonna go with impact here. And then feasibility here. All right, and we're gonna divide this, and we're gonna say low, high. Okay, so this is going to be low, high, right? And then if something is low impact and low feasibility, obviously that just doesn't make sense. We don't care about this. This is the most important quadrant, that is, high impact, high feasibility, but sometimes that's not possible because it's not feasible. Maybe something is gonna have very high impact but low feasibility, or it's going to have, medium impact, but it's gonna be highly feasible. And you really want to think about this. If you have access to all of these millions of agents that you want to build, if you have access to all of these, cool tech that you want to build, does it actually make sense to build it for your business? At the end of the day, it comes down to money. We do live in a, world where money is what matters. Money is the reason why your companies are operating. So we want to calculate if the AI that you're building actually, at the end of the day, is going to be making you money. All right, so just a note on agents, by the way. When it comes to high visibility, high impact agentic systems, probably some things that fall into that would be, if you have, you're probably gonna have a lot of tool usage in those tasks. It's probably going to be, kind of like a task that has a clear saving for you. From the industry perspective, I think a great example are telecommunication companies. I think that they are an incredible example of how agents can be applied, because they have this whole, kind of like a holy grail of telco. And telecommunication companies work on routers, right? You have millions of routers, like Verizon, for example, or like any other company, You have like millions of routers, they're connected all over the place. And how do you find and spot, actually it doesn't have to be, think about GPUs. Has any of you trained large language model or pre-trained model? All right, so how many GPUs do you use? Thousands.
I use 800 GPUs.
Right, but if we're thinking about like training of really, really large model, like, like Claude or whatever, have you trained any like very large models? No, okay. You can imagine you're using 1,000 GPUs. And let's say that a node goes off. To actually detect which node went off is like close to impossible. Perfect use case to use agents. Like you can use these technologies to locate a node that died or a router that went out. And if you build that system, for example, is also a great use case for a fully autonomous system. You can't just build a fully autonomous system though. You can't just say, okay, I'm a company, I'm a legacy company, especially if it's a legacy company, like if it's a telecommunication company or like, semiconductor company, doesn't matter. A legacy company, they've been around for 40 years, maybe longer. They have the infrastructure, they have a setup, they have everything, and then suddenly we hear these agents, they're easy to make, they're way cheaper than they used to be. You can't just like now be fully autonomous company. That's just impossible. You have to start from somewhere. So there are different levels of autonomy that you want to build. Usually it's like level 1 to level 5, where level 1 is you have the most human input, maybe the most deterministic, maybe, and level 5 is like this holy grail, fully autonomous system that you're building. I'm probably close to time, but without my slides. Okay, so back to money. When I give this talk, really the main portion of the talk is margin. How many of you actually know what margin is? Like when when you're looking at the stock market and you're like, they're talking about margin, no, and you're like, oh, I know it's a thing, but I don't really know what it is. And I'm kind of like, I'm not definitely not gonna say it out loud. I'm just gonna pretend like I do know what it is, and sure, that's a great stock to buy. So many of us, and that's not, You do know what margin is, though. So first thing to ask is, what is margin? Just think of it as profit, right? So it's going to be total revenue that you make minus the cost. To simplify things, that's what we're going to take in. We're building AI solutions. We work for maybe you work, some of you said you work for a corporation and you have this amazing AI idea. And you're like, I think we should utilize AI. And you want to go to your manager and you want to convince them that that's an incredible thing to do. And your manager is going to say, all right, set up a meeting and convince me that it is and how you're going to pitch it. And you're going to, talk about technology and this. So many millions of agents are going to change your life and we're going to da-da-da-da-da. The first question a manager is going to ask you is, how much money is this going to cost? Second question is like, am I going to make any money? What is the actual value that I'm getting of these millions of agents that you're going to build? So the question that everyone is going to ask you is, how much would you pay me to build you an AI solution? At the end of the day, if you're deciding whether or not you should build a solution, you want to understand how much money that's going to cost you at the end. So I do this, explain me like I'm for analogy with cookies and what revenue and margin is. But at the end of the day, we understood that $4 revenue, if it takes you $1 to bake a cookie, 4 minus 1 is 3, and $3 is going to be your profit. So $4 is revenue from selling one cookie, revenue. $1 is cost to make this cookie, cost of making. And I understand that I'm like writing caps and low caps together, so just ignore that. So $3 is our profit. Cool. Everything that we do going forward is going to be on that. So instead of selling it, we want to, instead of selling this cookie, we actually want to take this profit and put it in this magical cookie jar. And this magical cookie jar is going to give you back 10% every year. Every year is the magical cookie jar. All right? Okay. So the question here is, what is your $3 going to be worth 1 year from now? And then there's this whole thing that I'm going to be talking about, present value. All right. I do have notes for this on my phone. Okay. So I think, does anyone work on Wall Street? Is anyone like a Wall Street related person? Or like a financial institution or financial analyst or anything? All right, so on Wall Street, they, I guess, have a saying that your dollar today is not worth the same as your dollar in a year or tomorrow, whatever. It's actually worth less today than it is tomorrow. What it really means is, let's say, let's focus on this $3 profit for a cookie. If I tell you that if you put this cookie in a magical cookie jar and you're gonna, in a year, this is gonna give you $3 back, you're gonna make $3 back, you don't want to pay $3 for this cookie today. You want to pay something else, right? So this is how we're going to decide how much money we want to pay for our AI project for it to make sense in the future once our AI starts giving us a return back. Everybody's following me? All right. So the formula is very simple from high school. Our present value is 1 times rate of return, 1 plus. Never mind. Don't check my math. This is always on the screen for me. And this is our future amount. This is literally like your high school formula on interest. Okay, except that in this case, we call this present value, future value, rate of return. And we said this goes up every year. So, for $3 present value, if this compounds every year, it's 3.63. Okay, cool. So now that we established that, how do we actually decide what's this, if we if someone tells me you're going to make $3 in the future, what should I pay today? It's really just, extracting this from this formula. So it's going to be your future value with Okay. By the way, this is all compounded over time. Great. So this is we call this discount. It's essentially discounted back to today's value. And our present value, which you want to pay today, is $273, I believe. Yes, it is. $273. Okay. So when you're selling your AI solution to your manager, you actually want to tell them the money that I need, the money I want you to pay me is $2.73. And the AI tomorrow that we build is going to give us $3 back. Obviously, this works with large money, way more money than I just told you about. I have this slide that talks about agents and how you can do the same thing for agents that I cannot show you right now. But you can think of it as you can translate this easily into tokens. And you can say something like one completed task is going to cost you $1 in tokens plus tools plus review, and then you can charge $4 for that task, and that's going to give you gross margin of $3, which is 75%. So agents have this, gross margin is going to be essentially profit for making and selling. We have kind of like a formula that you can translate this into agentic way to convince your manager what's going to cost it. So the new formula of the unit cost of one agent run, we have cost per run. Cost per run. By the way, this is all made up just to kind of like prove the point. You can definitely, depending on the service that you use, you can probably figure this out. Okay, so we can say tokens in plus tokens out plus price per token plus tool per API cost plus escalation rate plus human review rate, like a human rate, that is going to be your cost per run. And you can essentially use that to plug in to figure out what is your total run going to cost. If you have, for example, if model costs, 1.6, I want 200,000 tokens and so on, this is going to give you maybe $2.65 per run. Okay, so how do we decide when we discount it back whether or not this makes sense? We are going to plug everything in, and we are going to be calculating something called net present value, which is essentially going to tell you the money that your project is going to be worth sometimes in the future. Considering the time, I'm not going to go into super details on this, but you can look it up, and I don't have my slides, so it kind of involves a bunch of numbers and examples. But the whole thing is you want this to be positive, and you calculate a bunch of these things, and you can even do like a little beautiful visual projection of the future to your manager and say, the first year we're going to be in a negative. But then, we're slowly going to be less negative or like whatever, and then at one point we're going to be positive. And this is going to be year 5 when we're going to make $100 billion. Great. All right. Final thoughts. Evaluation versus business impact, kind of like a translation layer. A while back, at the end of the day, it's important to think about technical metrics when you do evaluation, but also business metrics when you do evaluation. So actually, the first thing that I do in all my projects with anyone is I define success criteria, right? When you're, I don't know if you interviewed people ever, but first thing I ask when I interview people is, what would you ask to a CTO that you're working a project for? And if they don't say success criteria, negative point. No, I'm just joking. But yeah, success criteria, I always define it as the first thing that I set and define with anything that you're working on, because that's essentially what you're optimizing for. You set up your baseline, and then you go from there. And the same, I think that a lot of times when we talk about agents, we talk about these evaluation metrics from the technical perspective, but we don't really talk about how they translate into business metrics or KPIs. So, you can translate some of these metrics like task completion rate, you can translate it into cost reduction. Precision, if you have like a fraud model or something, you can say, okay, well, if you want your fewer false positives forwarded, that might in the future cause reduced investigation costs or something like that. If you have tool call accuracy and how much the model is hallucinating, whether it's like write API, write arguments or something like that, essentially that in the future translates to risk and compliance. Wrong actions can mean rework. If you're in a regulated industry, you can get audited and so on. Latency and cost per run, that can cost you in gross margins. Speed drives, the future profit and so on. So I'm gonna wrap it up here, and I'm gonna open up for questions. Thank you for coming to my old school lecture.